welcome to cycle 6 of module 7 and 8. And you notice we skipped cycle 5 because our class is doing our assessment in cycle 5, which is the start of term 3. So we are going from the cycle 4 video to the cycle 6 video, so you haven't missed one. Firstly, we're going to start with our do now. So I want you to look at these graphs here. We see a line graph on the left, a column graph on the right, and I want you to identify 3 trends in the graph, and they both depict investment in research and development. So hopefully you're getting better at identifying trends from a graph and making sure that you are looking at what is there and not making any inferences here, but are really describing the trends in detail, making sure you're using as many adjectives as possible and using both the X and Y axes, specifically referring to data, points where you see it go up specifically. So for example, it is line 14, which is defense. If you mentioned that investment in that was quite steady until 2019 and 2020, where it jumped from $2 billion to, I guess, just over $3 billion, you're using specific numbers and values from the X and Y axes. So in this video, we're looking at our inquiry questions similar to the end of last cycle of how do economic, social, and political influences affect scientific research. We're going to be looking at the impacts that governments and large corporations have on research, and then we're going to evaluate how personal, cultural, and socio-economic perspectives can influence the direction of research. So part 1, we're going to look at the impacts that governments and large corporations have on research. So I guess in the 15th to 19th century, any research was self-funded and it relied on the wealthy funding investigations. However, until the late 19th and early 20th century, where research was increasingly funded by industry, philanthropy, and universities. So specifically after World War II, governments funded scientific research, but how much and how they funded it, there's quite a large variation. So in Australia, currently, the federal government funds research through business industries, universities, and higher education institutions, government research organizations, and non-government research institutions. So there's quite a few examples that you can see there of where the government provides its funds. So one example here we see is the sugar industry. This is just an example to, I guess, get us thinking of how people, and linking back into one of our older modules in terms of looking at how information may be suppressed. So in 2016, an article in the JAMA Internal Medicine suggested that 5 decades of research into nutrition and heart disease may have been shaped by the sugar industry. And that was because the Sugar Research Foundation paid Harvard scientists $50,000 to publish a 1967 review on sugar, fat, and heart disease. The studies used in the review were chosen by the Sugar Group, and the article minimized the link between sugar and heart health. And so this is a way that I guess we would have looked at before in terms of misinterpreting information, and the fact that governments, I guess large corporations here, like Coca-Cola, providing funding to researchers to downplay the links between their sugary drinks and obesity. So this is an example here, and we're going to look at an example similar to this in our learning task 1. And so the idea that we're going to read the article on where University of Sydney had to pull down their claim about elderberries and the way that they fight flu. And that was because the research was part funded by a company called Pharmacare, which sells elderberry-based flu remedies. So they actually had a conflict of interest here that they failed to publicize, and therefore the study was actually had to be pulled because it didn't actually align with the ethical part of research here in terms of identifying conflicts of interest. And next, we're going to look at some more corporations and market opportunities and how they influence research. So industry-sponsored research is an essential component of research and the way that it's funded internationally. So that most corporations fund research that develops solutions to problems, as well as fostering innovation. And an important driver of the sponsorship of this research is profitability. So the outcomes of this research will add to the revenue of the corporation itself. So an example here is Google, and we have on the right here all of the different research areas that Google are a part of. And it's estimated that they spent $21.4 billion US in 2018 on research projects, which included the development of driver vehicles and quantum computers. However, they actually think that might not be the full picture of their research. And we see here the first discussion on the idea of research and development. And so while they fund research, 80 cents for the dollar is spent on development, whereas 20 cents are spent on research. So quite a different few ideas there. So learning task 2, I want you to look at a company that's not Google and look at the marketing research that they may have undertaken and how that impacts on their product, and answer the question about evaluating the importance of scientific research to marketing. The next is the idea of funding for research. So we know that funding for research can come from research grants from the government, universities, contracted research from a university, or actually buying a consultation from university staff when researching an area that they're an expert in. So government funding of research can be through either competitive research grants or research block grants, which are given to support research programs, whereas the competitive one is where proposals are put forward and they're assessed based on their merit. So the Australian Competitive Grants Register provides funding to projects that align with schemes funded by the government. And these areas allocate funding depending on the national priorities and social issues at the time. So in Australia, between 2015 and 2016, Australia spent $31 billion on research and development, which represents about 1.9% of Australia's GDP, or gross domestic profit. And this placed Australia 18th on the list of OECD countries in terms of their expenditure on research and development. And then in 2017 to 2018, it set aside $10 billion for research and development. So we see it did lower between those years. And these funds are allocated to research programs at universities or businesses, government agencies. And we see here the research priority areas. So the priority areas look at food, soil, water, transport, cybersecurity, energy. And then we see the National Health and Medical Research Council also has different health issues that they look into. And we see here mental health is a specific one, electromagnetic energy, and they emphasize research that targets prevention, treatment, management, and cure of health diseases. So in the 2018 to 2023 research priority areas, there was a change in the research areas that the Australian government prioritised. So they looked into decarbonising the energy system and robotics, artificial intelligence, augmented reality, and virtual reality, and that some government initiatives are designed to support research for more extended periods. So the Medical Research Future Fund is an innovative research funding model which uses the interest gained by government investments for medical research. And the Australian government encouraged businesses and industry groups to engage in research and development. And there is the ARC Linkage Grant Scheme, which funds collaborative research projects between academics and industry. And then there's also the CRC, which business and industry groups that invest in research and development receive tax concessions. So in terms of changing the funding model in Australia, we've seen that happen from the start of 2018 when the original budget was cut for research and development. So in Learning Task 3, you're going to look at the research and development trends happening here. From the federal government, and looking at, looking at information and being identified trends, a working scientifically skilled, that is really important, and being able to see what trends we've seen over time with Australia's investment in research and development. The next we have Indigenous cultural knowledge. So we're starting to look at our next descriptor. So if I just go back here, we're looking at how we're still looking at our government and large corporations, but in this case, we're looking at Indigenous cultural and intellectual property. So when we know that Indigenous cultural knowledge relates highly to, I guess, that bioprospecting model and looking at ways we can use that information to benefit human health. And making sure that Indigenous cultural knowledge is recognised and that research companies actively work with Indigenous people and people that are in specific cultural areas to recognise the Indigenous property, but also work with them to best keep that relationship and work towards reconciliation while also a mutually beneficial relationship. So we're looking at the CSIRO, for example, work with Indigenous communities, such as tracking the green turtle populations in Western Australia, the development of different glues, and on land care and fire management strategies. So we're also looking at some of the different. So this specific example of smoke bush is traditionally used by Aboriginal people as a medicine. And the US government actually noticed that it could destroy the HIV virus, and that they actually filed for a patent in 1993. And the patents gave the US government the exclusive rights to smoke bush, and then were able to license it for others as they saw fit. So, what happened is that this actually did not benefit Indigenous people, and that again we see the Western Australian government, it licensed the rights to smoke bush to MRAD, which is an Australian pharmaceutical company, and that they contributed $1.65 million to the government to have exclusive rights. And that there was no actual acknowledgement, royalties, compensation, acknowledgement of international and cultural property for Indigenous people. So it meant that Aboriginal people could no longer access it without permission. So there are quite a few different ways in which companies here can work against the measures we've put in place to acknowledge the intellectual and cultural property by using their big business and the money they have to capitalize on these bioproducts. There's another example here about the another Indigenous plant that this one is in South Africa, and that they commercialized this product called the Hoodia for pharmaceutical benefits as an appetite suppressant without actually sharing any of the benefits with the Sands people of South Africa. And then the last plant is our neem plant, which is native to India, used as a pesticide, but now exploited by national companies. So all of these cases show that Indigenous people have a strong role in nurturing native plants, and that their role here can be overtaken by big businesses who just want to make for their economic and political gain, I guess. Next is our part 2, and we're looking at how personal, cultural, and socio-economic perspectives influence scientific research. And the first is got to do with diet. So people with high incomes have good diets, healthier weights, and better health outcomes compared to Australians from Indigenous and minority cultural groups. And then because Australia is so multicultural, there are different perceptions about diet and health, and that the cultural norms associated with diets actually vary between ethnic groups, even though they're in the same geographical area. And that the different cuisines significantly impact the health of different communities. So some diets, such as the Mediterranean diet, have actually been investigated scientifically, so controlled double-blind studies. And there's more studies being undertaken in terms of the Mediterranean diet. And some of these are, I guess, influenced by different communities and the diets which they are using in their communities. So in Learning Task 4, we're going to look at the Australian Dietary Guidelines. And in 2013, it was announced by the Australian government that there will be a review into the dietary guidelines, and making sure that the guidelines are using the best and most recent scientific evidence. And this process, however, the consultation process alone was only closed in March 2021. So 8 years and $2.5 million has been put into changing the guidelines. So there's some questions that I want you to answer in terms of predicting why the process took so long. And then I want you to use guidelines 2 and 3 from the Australian Dietary Guidelines to explore how some diet trends may go against these guidelines, and see where, through research, you'll be able to see the differences between some of the most common diets, like the ketogenic diet, the Mediterranean diet, and then I think there's one more in your outlines there, but you can choose any different diets that you know about and see how they may be different to the guidelines that are put forward by the Australian government. Then we move to traditional medical treatment. So conventional medicine is practice that is learnt in medical faculties at universities around the world. And then anything that is not in medicine, dentistry, nursing, or pharmacy is considered non-conventional medicines. And these are also referred to as traditional medicines, and they're closely associated with different cultures. They may also be called complementary medicine. They usually fall into two categories: natural products or mind-body practices. And they're quite popular in Australia. And in a survey, approximately 70% of people had used at least one form of traditional and complementary medicine. So in Learning Task 5, we're going to be looking at how the TGA assesses natural therapies and how private health insurance excludes some natural therapies and why they would be excluded. You're going to assess the importance of regulating alternative and complementary medicines. And then there is also a guide that's given to clinicians, so I guess they're GPs, doctors, that are able to discuss with their patients if they want to undertake clinical medicine. So using your knowledge of evidence and research, you're going to create a few statements to inform people about the evidence that they can use to make an informed decision. And the last has got to do with mining practices. So these are, again, a polarizing issue for society, and increased public awareness of the consequences of mining has caused the industry to reflect and change their practices moving forward. Mining operations are required to comply with environmental standards, and the CSIRO actually conducted a study on Australian attitudes towards mining. And the research concluded that not only do they need an actual license to mine, but they also need a social license. So people in that community need to actually have their voices heard before the mining practices can be put in place. So in Learning Task 6, you're going to review the data from the survey that was conducted in 2017 and published in 2020. And you're going to do some data analysis there. The survey was a national survey, but only conducted on 8,020 citizens. So I want you to comment on whether you think this is a valid survey using your knowledge of sample size and the different types of ways you can do an investigation. Looking at the distribution of people in the survey. So did the distribution make the survey valid? Again, you're going to be looking at some trends visible in the data, and then creating a graph using the mean scores from the positions held by people. And there's a few different questions there to really make you think about the working scientifically skills that go behind creating graphs and displaying data. That concludes our Cycle 6 video. Make sure you update your inquiry question log for the how do economic, social, and political influences affect scientific research question, and complete the Google form. There aren't as many HSC questions about this section of the syllabus, but it doesn't mean that it's not important. So being able to apply your information and know it really clearly would be helpful for the HSC exam.